Hello students, this is Irshad. Welcome to class 10 ICSE Physics. In today's class, we are going to discuss current electricity exercise 8b. I will help you understand the concepts and numericals in a simple and easy way. So let's start. Question 1. The diagram in figure 8.42 shows a cell of EMF E equal 4 volt and the internal resistance R equal to 2 ohms. Connected to an external resistance R ohms, the meter A measures the current in the circuit and the voltmeter V measure the terminal voltage across the cell. What will be the reading of the ammeter and voltmeter when the key is open, the key is closed? What given in the question? First, we have to underline it. Electromotive force given 4 volt, internal resistance 2 ohms, external 8. What we need to find? The measure the current in the circuit. I mean ammeter, voltmeter readings we need to find out. As we know when the circuit is open, no current flows through it. So when key is open, the circuit is incomplete. The circuit is open. You will write I equal to 0. Ammeter read 0, 0. And the voltmeter reads. So next he asks terminal voltage. Well, when the circuit is open, the electromotive force of the cell is equal to terminal voltage. So we'll write here the terminal voltage V equal to 4 volt. When the key is closed, definitely the current flows. The current flows from higher potential to lower potential. This is the direction of current in the circuit, I current. When current flows through it, when the circuit is closed, the ammeter reads the current. In this case, the current is not equal to 0. We are going to find first the internal resistance. I mean the total equivalent resistance. So I will write here R equivalent equal to external resistance plus internal resistance. Both are in series. Then R equal to 8 ohm, external, internal 2, that equal 10 ohms. Given electromotive force epsilon equal to 4 volt. Epsilon equal 4. Epsilon equal to IR. R equivalent. Then 4 equal to I into 10. Then I equal to 0.4 ampere. So when the current flows through it, the ammeter reads 0.4 ampere of current. Let's find voltage drop. Voltage drop is represented by small v. Small v equal to capital I, small r, that is internal resistance. We found it is 0.4. Current internal resistance 2 given, that equal to 0.8 volt. This is the internal resistance. So it is voltage drop. Therefore, electromotive force equal to terminal voltage plus voltage drop. Then V equal to epsilon minus small v. That implies V equal to 4 minus 0.8 equal to 3.2 volt. This is the terminal voltage when the circuit is closed. Question 2. A battery of EMF 6 volt supplies current through a circuit in which the resistance can be changed. A high resistance voltmeter is connected across the battery. When the current is 3 amperes, the voltmeter reads 3.4 volt. Find the internal resistance of the battery. Find the internal resistance of the battery. So what is given? This is the epsilon, electromotive force of the cell. This is the terminal voltage, capital V. 3 amperes of current, I it is. We have to find the internal resistance of the battery. Direct formula will use epsilon equal to terminal voltage plus voltage drop. Epsilon 6 terminal voltage 3.4 plus, using Ohm's law, the voltage drop can be written as I into small r. 6 minus 3.4 equal to IR. 2.8 equal to, what is the current here? 3 given. 3 into R. There R equal to, it is 2.6 it is. We can subtract 2.6. Then R equal to 2.6 by 3. Divide 2.6 by 3, what will you get? 2.6. 2.6 divided by 3. You will get 0.8. So R equal to 0.867 ohms. This is the internal resistance. So what we have done here, EMF of the cell 6 volt, terminal voltage 3.4 volt, current 3 amperes. Need to find the internal resistance. Direct formula I have written. When the circuit is closed, the electromotive force of the cell equal to terminal voltage plus voltage drop. 6 equal to 3.4 plus IR. IR equal to 6 minus 3.4, that is 2.6 into 3 into R. Then R equal to 2.6 by 3. Then R equal to 0.67 ohms. Question 3. SL of EMF 1.8 volt, internal resistance 2 ohms, is connected in series with an ammeter of resistance 0.7 ampere and a resistor of 4.5 ohms as shown in the figure 8.43. What would be the reading of the ammeter? What is the potential difference across the terminals of the cell? So what is given in the question? Epsilon, internal resistance small r, external resistance capital R, ammeter resistance 0.7. So total resistance, I will write equivalent resistance. So what will you take here? 2 ohms, 4.5 and 0.7. Then R equivalent equal to 2 for internal, 4.5 for external, 0.7 for ammeter resistance. Then R equivalent equal to 6.5. That is 4.5 plus 2 plus 0.7. We will get 7.2 ohms. This is the total resistance in the circuit, 7.2 ohms. We need to find the reading of the ammeter. So I will use the Ohm's law to find the resistance current in the complete circuit. Electromotive force given 1.8. So 1.8 equal to I, we don't know. R is given 7.2. I equal to 1.8 by 7.2. Then I equal to, let's divide 1.8 divided by 7.2. Then current you will get 0.25 amperes. 0.25 amperes. This is the current. What is the potential difference across the terminals of the cell? Across the terminals of the cell. The next page I will write here. Epsilon equal to V plus V. Electromotive force of the cell equal to potential drop plus terminal voltage. Potential drop represented by V, small v. Voltage, terminal voltage represented by capital V. Then V equal to epsilon minus small v. Epsilon given 1.8 minus, this is the voltage drop. I will write capital I, small r it is, that equal to 1.8. Current we found 0.25 ampere. The resistance is 2 ohms. 2, that equal to 1.8 minus 0.5, that equal to 1.3 volt. This is a voltage, terminal voltage. Question 4. The music system draws a current of 400 milliampere when connected to a 12-volt battery. What is the resistance of the music system? The music system is left playing for several hours, and finally the battery voltage drops until the current drops to 320 milliampere. At what battery voltage does the music system stop playing? Okay, we will find here given current, battery. This is the current. Okay, first by using these two, current and battery, I will find the resistance. Equal to I equal to epsilon. Then epsilon equal to I into R. 12 current is given milliamperes. So I will convert into ampere. 0.4 ampere into resistance R. Then R equal to 12 by 0.4. R equal to 120 by 4. R equal to 30 ohms. Now, what voltage does the music system stop playing? Okay, current given here 320 amperes, resistance is remains same. Then I will write here V equal to IR. I is here 0.32. It is given milliampere, so I converted into ampere. Resistance given 30, means we found 30. That equal to 3.2 into 3. volt. So the music system stop playing at 9.6 volt. The question number 5. A cell of EMF E and internal resistance R sends a current of 1 ampere when it is connected to an external resistance 1.9 ohms, but it sends a current of 0.5 ampere when it is connected to an external resistance of 3.9 ohms. Calculate the value of E and R. What is given for the first statement? This is I. External resistance is 1.9 it is. I will write epsilon electromotive force equal to terminal voltage plus internal resistance. Epsilon equal to IR plus IR, where small r is the internal resistance, capital R is the external resistance. I will take common out. Epsilon equal to I of R plus R. Epsilon equal to I value is 1, external resistance 1.9 ohm plus internal resistance small r. So finally we have sigma equal to, or epsilon equal to 1.9 plus r. This is the equation 1. Similarly, for the second statement, epsilon equal to current 0.5 ampere, external resistance 3.9 plus internal R. This is the equation 2. Equate the equation 1 equal to 2. 1.9 plus R equal to 0.5 into 3.9 plus 0.5 R. R minus 0.5 R equal to, just multiply 0.5 into 3.9, will get 1.95, 1.95, 1.95 minus 1.9 minus 1.9, we will get 0.05. So here we will get 0.5 R equal to 0.05. R equal to 0.05 divided by 0.5. Therefore, R equal to 0.1 ohm. 0.1 ohm. This is the internal resistance. That is R equal to, small r equal to 0.1 ohm. Now we are going to find the external electromotive force. Epsilon equal to (1.9) 1.9 plus 0.1. Epsilon equal to 2 volt. So the electromotive force of the cell is 2 volt. Question question 6. Two resistors having resistance 8 ohm, 12 ohm are connected in parallel. Find their equivalent resistance. This is the R1, R2 arranged in parallel. So we have R equivalent equal to 1 by R1 plus 1 by R2, 1 by 8 plus 1 by 12, 1 by 8, 1 by 12. Okay, LCM you will get 24, that equal to with 3's with 2's by 24, that equal to 5 by 24. R equivalent equal to 24 by 5, that equal to 24 divided by 5, 4.8 ohms, 4.8 ohms. 4 resistors, each of resistance 5 ohms, are connected parallel to each other. So how many resistors here? 4, each is 5, connected in parallel. So we'll write here same formula we'll use, 1 by R equivalent equal to 1 by R1 plus 1 by R2 plus 1 by R3 plus 1 by R4, that equal to 1 by 5 plus 1 by 5 plus 1 by 5 plus 1 by 5. So resistance of each resistor is same, that is 5 ohms, that equal to 4 by 5. It is equal to R equivalent, 1 by R equivalent. Then R equivalent equal to 5 by 4. Therefore R equivalent equal to 1.25 ohms. You have 3 resistors of values 2, 3 and 5 ohms. How will you join them so that the total resistance is less than 1 ohm? Less than 1 ohm. Draw a diagram, find the total resistance. 2 ohms, 3 ohms, 5 ohms. 3 resistors given. Let us take the R1, R2, R3. Now these 3 resistors are connected in parallel to each other, then to reduce the resistance, we'll write here 1 by R equivalent equal to 1 by 2 plus 1 by 3 plus 1 by 5. What is the LCM you will get? LCM will get 1 by 2, 1 by 3 plus 1 by 5. Okay, I'll see the LCM here, 2 comma 3 comma 5, with 2, 3 and 5. In 30 is a LCM, then you will get 15 plus 10 plus 6 by 30, that equal to 31 by 30. Then R equivalent equal to 30 by 31. Now divide 30 divided by 31. 0 point R equivalent equal to 0.967 ohms. So to get the total resistance less than 1, it must be connected in parallel to each other. Okay, diagram we'll see now. This is the diagram. Given 2 ohms, 3 ohms, and the 5 ohms. And we found the equivalent resistance equal to 0.967 ohms, less than 1 volt, less than 1 ohms. The next one, 3 resistors each of 2 ohm are connected together so that their total resistance is 3 ohms. Trace diagram so that their arrangement and check it by the calculation. 3 resistors each of 6 ohms. So this is also arranged in parallel to each other. When it is arranged parallel, we will write here R equivalent equal to 1 by 2 plus 1 by 2 plus 1 by 2. No. This is not. 2 arranged in parallel. With the last one, you will get in series. You will get here 2 by 2. Then R equivalent equal to 1 ohm. Arrangement see here. This is the point A. One resistor. Second resistor. Third resistor. Each one is 2 ohms. 2 ohms. 2 ohms. So resultant of these two is 1 ohm, and the resultant one is equal series with 2 ohms. So therefore, the total resistance RT equal to 1 plus 2, that equal to 3 ohms. Calculate the equivalent resistance between the points A and B in figure 8.44. Each resistance is 2 ohms. Okay, these two are in series. These two are parallel to each other. So already we found when it is connected in parallel, the equivalent resistance is 1 ohm. Just now we have seen. Then the total resistance or equivalent resistance equal to 2 plus 2 plus 1 equal to 5 ohms. So finally we have done 10 problems today. The coming problems we will do in the coming class. Anybody have a doubt, please send a message. In the coming class, we will solve 10 more questions. The same exercise. Bye and take care of you.